Okay, so this is about just momentum and also a little bit about conservation of momentum. So first of all, momentum is the product of the mass and the velocity of an object, okay? So in terms of calculating momentum, that's our calculation, and that's also how we define it as being the product of the mass and the velocity of an object. Now, because it's looking into velocity, we have to be really careful because we're dealing with vectors. It means that it has a direction. So one of the things we have to be really careful for, and we have to often put ourselves in the equations, is we need to be looking at positive directions and negative directions. Okay, so that's something to bear in mind. We'll look at a little bit with some problems later on. So mass, remember, should be in kilograms, our velocity in meters per second, so our unit for momentum would be kilograms meters per second. So most of the time we're going to be looking at the idea of a collision. We could also look at an explosion as well, but we're kind of looking in terms of momentum, usually in terms of collisions and explosions for the IB. So one of the things we talk about is the conservation of momentum. This is usually what our problems are going to be involved with. And we say for the conservation of momentum, we have to use kind of two parts for this. Now, the first thing is that this is always, when we're looking, it's for an isolated system. By an isolated system, we mean there are no external forces that are acting. So I'm ignoring air resistance, I'm ignoring friction. We are assuming that it is a perfect isolated system. Okay, so you always need to say that part. So for an isolated system, the total, and people always forget the word total, the total momentum before is equal to the total momentum after the collision, the explosion. Okay, so for an isolated system, the total momentum before the collision is equal to the total momentum after the collision. It's a definition that you do need to know. They've been in MCQs. They've also been often 2 markers for written responses in paper 2. So we're going to look at a couple of little collisions here. So the first one I'm going to look at is just a really simple collision. I've got object A, and object A is moving towards object B, and object B is stationary. So I have object A, and it's moving with a velocity of 5 meters per second, and object B is stationary. They both have a mass of 10 kilograms. I've just not put my units down. And they are going to combine and stick together. So we have our new system, our AB system. Okay, and I want to know the speed of which they are now moving after. So I've put a little line in to draw this out, and this is one of my big recommendations until you feel confident with momentum and conservation of momentum questions, is often do a little sketch like this. So I'm going to look at my total momentum before the collision. So momentum of A plus the momentum of B. So MV and MV. 10 by 5, which is 50 kilograms meters per second for object A. Object B, because it's not moving, essentially it has no momentum. Okay, because remember, it's a product of its velocity. So the total momentum, if I add the two of these together, 50 plus 0, is 50 kilograms meters per second. I should also notice at this point I have said that my positive direction is moving to the right. Okay, so I decide the positive direction. Now, conservation of momentum tells me, for an isolated system, total momentum before is equal to the total momentum after. So this part here, I can bring this across to help me solve my second section. So the total momentum after is the mass of AB and the velocity of AB. Again, because this time they're combined, I consider it as one full option. So 50 is equal to 20, because this time I've got both their masses together, so the mass of this system is 10 plus 10 to give me 20, to find out what their velocity is. Simple rearrange at this point, 50 by 20 would be 2.5 meters per second. So that's a really nice simple one. They could have both of these moving. Again, if you had those, you'd have to add those together, but if they combine or they say they stick together, so the words that you might look for in a question would be combine or they stick. Okay, if they give you those, this is the sort of solution, this is the sort of problem that you are looking at. Now, one of their other ones they like, and this is usually a little bit harder, is a head-on collision. And this is where you have to be really careful about those positives and negatives. So again, I'm going to look at A, and I'm going to look at B. So I've got my A, and I've got my product, so my object B. And what I want to see is, I know they're both moving head on. They both, again, have a mass of 10 kilograms. A has a velocity of 5 meters per second and B has a velocity of 10 meters per second. So B is moving a lot quicker, or double the speed that my 5 is moving at. And I can tell you, after the collision, object A moves or rebounds in the opposite direction at 8 meters per second. So what I want to do in this case, again, is I'm going to look at them in before compared to my after. So before the collision, I'm going to look at my momentum of A. So mass times velocity, 10 by 5, that's 50 kilograms meters per second. My object B, my mass is 10, my velocity is also 10, but this is moving in the opposite direction. Remember, it's a vector, so I'm going to have to use my positives and negatives here. So it's actually moving at minus 10 meters per second, because I've said that the positive direction is moving to the right. Okay, so in this case, my total momentum, so my momentum of B is minus 100 kilograms meters per second. So if I add these together, 50 plus minus 100 gives me a total momentum of minus 50. So again, I've worked it out on this side. My total momentum is here. I can bring this across to my total momentum on the other side. Again, this total momentum here is the momentum of A plus the momentum of B. Well, if I work out my A's momentum, that's 10 by minus 8, because again, we're moving in the opposite direction, so that's minus 80. That gives me a total momentum, that gives me a minus 50 is equal to minus 80 plus the momentum of B. So the momentum of B must be 30. So minus 80 plus 30 to give me a total momentum of minus B there. I was running out of page to write on, so I hope that makes sense. So momentum of B is mass times velocity. We know that it's equal to 30, because minus 50 equals minus 80 plus 30. 10 by velocity. So my velocity is 30 divided by 10 to give me 3. Now this is positive, so it tells me that this is moving with V is equal to 3, but it's also must be moving to the right because it's in the positive direction. And I worked out that positive because this was plus 30 over here. So my plus 30 divided by 10, so this is plus 3. So again, being really careful with those positive and negative values. I'm going to show you another one in terms of the change in momentum of a system. So this is not conservation of momentum, this is just change in momentum. But it is a really common MCQ. So we might be looking at another rebound, but a rebound off a wall. So we have the ball of mass M, hits the wall, rebounds off. So we're saying its initial velocity is u and its final velocity is v. So our change in momentum is the momentum before minus the momentum after. So in this case, mu minus mv. But my v is moving in the opposite direction, so it should be a negative sign. So I have mu minus mv. Well, in this case, that's mu plus mv. So m, or brackets, u plus v. So just kind of being in a little kind of situation to think about those positive and negatives there. We also have ones, for example, I'm just going to show you a quick explosion. So we might have a gun firing out a bullet. Okay, if I have a gun firing out a bullet, momentum before, they're both stationary, so the momentum before is going to equal 0. So the momentum after, I should say total momentum after has also got to equal 0. So again, we have momentum of the gun is equal to the momentum of the bullet. Well, if the bullet is moving in this direction, okay, we know this is going to be positive. The momentum of the gun has to be negative to cancel it out. So that's why we get the gun moves backwards when the bullet moves forwards, and we get that recoil. So just again, it's another one for the explosion. You have something moving forwards, has to move backwards because our total momentum, our conservation of momentum has to equal there. And that one is conservation of momentum.